All right, people. Today we're going to cover a little Piston Tech. These pistons that I bought these for an engine build that I'm doing, and I could have went with a Molly piston, which would have been every piston would have been more expensive. These are very expensive pistons. I got them at a very good price. The problem is the compression height. I'm putting together a 427 Windsor. So it's a stroker motor, but it's set up for, it's actually not a 5.7 rod. It's supposed to be a 6125. So it's going to be a 400 cubic inch Ford rod, basically. This is a 350. This is a 5.7 rod. So it's a little bit taller. But if you look right there, there's a difference. You see that difference in compression height? That's what that's called. The difference between the center of the pin. You measure from the center of that pin to the top of the piston, the effective deck of the engine, or deck of the piston, deck height of the piston. That's your compression height. And you see how much lower this compression height is? Well, that's where I run into a problem. Because when I get, it should have been a piston like this, which, you know what, I'm going to kick my ass. I'm going to kick my ass. I don't have a tape measure handy. Hang on. We're going to measure this out. These are SRP, Keith Black SRP J&E forged pistons. These are pretty damn good pistons. I got these at a good price too. No, they're I'm telling you, it's a 4125. Pretty damn close. Let's see what we got here. I can use those. No, these are a 410. Oh, let me take one more quick look here. They're close. I might have been able to use them. Probably would have been able to use these son of a bitches. I had Jim put them on there. These would have worked fine. Well, kicking myself in the ass now, right? But this is a $1,500 set of pistons. This is a good shit. This is for your, I mean, yeah, these will handle 500 horse without any problem. But you see the girdle? It's got a skirt girdle on it. You see that? This one does not, but this has got a girdle around the skirt. This is built for your 600 to 1,000 horsepower engines. And it's already been milled. Hell, it's still got a little milling on it. This has been milled for the larger valves. This is good shit. But the compression height, this one's got the correct compression height. I probably could have went with 6125 pistons or rods with this one. So just take these rods out. And then this is full floating too. So if you don't know, full floating is when you run your wrist pin and your rod isn't stuck into place. See that? And I can turn that wrist pin in there. It's got retainers in it. Do you see the retainers in there? So this is a full floating piston and rod. But it's got a 5.7 rod on it. This is built for a 383 or a 350, 355, 377, depending on which crank you use. That's your 5.7 rod. The rods I need are 6125, which is another inch higher, right? We go with the 6125 rod, and this compression height, we got a match set. We're good to go. Which I could have done. All I had to do was order a set of fucking rods. And I had the pistons here. But these are 500 horse pistons. We're talking about a 650 horse engine. So we go with the good shit, right? Lunati. No. Weisico. Sorry. Weisico piston. Still the same. Same. Lunati, Weisico, high dollar, high-end products. Very good. And we're going to be using 1/8" rings. These have got the purple. They're marked purple. I think goes on top. Yellow on bottom. And these are 1/8" rings. So you always want to check to make sure. Do I have the right ones? And you see, yes, I got the right shit. These are probably going to be not what I expected. I expected a closed loop. I expected them to be a little bit bigger. I may end up ordering different rings. I swear these are the ones I ordered. I don't know. I thought the ones that I got were, I don't know, older manufacturer. These are Molly, but I expected them to be a closed, which they come bigger, and you cut them to fit, and then you put them down into the cylinder wall like that, and you mark them because they're going to be larger than what the cylinder wall actually is. And then you cut them, and you cut them so that when they're in the cylinder wall, they'll shrink down a bit, and you only want, 5 thousandths, 8 thousandths at the most, but you probably want 4 to 5 thousandths is what you generally want. That's because when the engine warms up, these are going to grow. When steel gets hot, it grows, it expands. So these are going to grow, and they're going to grow this way, right? And that point is going to get closer together. And you cut them with a cutoff wheel that I showed in a previous video. You get that cutoff wheel and you mark it, and you'll sit there, and your blade's like this, and you just put it on that blade and you grind it down to the perfect length that you need. That way when you put them in there, what you get is blow-by, right? Every engine's going to have blow-by. And that's when you have that gap right there, and then when you put your other ring in, you line it up over here. So you got a gap over here and a gap over here, and then you've got gaps in your oil rings, and you spread them around too, so that you don't get compression. This compression, some of it's going to make it by that closed gap or a closed loop of the ring. Some of it's going to get by, but you want to minimize that blow by. And you do that by getting a closed loop ring or an oversized ring. You grind it down to fit so that when it's sitting in the cylinder, you got a little bitty gap like that versus a gap like that. Because factory rings, you put them in, they have a gap about like that. And of course you put another one, you counter set your gaps, but there still is more compression that gets by. So that's the way you do that shit. I don't know what else to say other than if you do a full floater piston, make sure you have the right retainers. They make different sizes of retainers for these little ridges in here. These retainers right here, I want to say they're a 1/16 retainer, and these look like they take the little rings. It's like a little piece of spring that goes in there. And these actually take clips. They're different. These actually look more like this. If you shrink that down times 100, then that's what goes into here. It's like a snap ring. But the ones that go into this, I believe, are the little springy wire style. It almost looks like a piece of wire spring that snaps in there. You want to make sure that's the right size, because they make different sizes. And if it doesn't snap down in there properly, it may look like it's snapped down in there, but it won't be. That fucker will come out and end up bouncing around in your cylinder wall, and then score the hell out of your cylinder wall and fuck up some shit. You don't want that. So that's your full floater piston with a wrist pin, which, you know, wrist pins are pretty basic. The length will matter because you want it to come up to that ridge right there. Another problem I had, the rods that I bought, I had to buy 6.385 rods. That's a big block Chevy rod for a 454. But it works with the compression height of that piston. That's probably why I got these so cheap, because somebody figured we got a problem. We cannot put these rods in this engine. Well, excuse me. When you know somebody like Jim, you can do it, because Jim Cameron is a very, very exceptional machinist, and he is in the process of narrowing my rods right now. I didn't know what they called it. I was like, hey, these rods are too big. I'm not going to fit them in the engine. I need to take the shoulder off of the bottom end of these rods. Oh yeah, I used to narrow Ford rods all the time. I can do these too. So, and I know it's a 427 Windsor, it's a Ford engine, but it's got Chevy journals on the crank. It's an Eagle crank. It's got Cleveland mains. It's got 2.1 Chevy rod journals, and it takes Chevy rods. I know that sounds weird. I know you think it's a Frankenstein motor, but when you want power out of a Ford, that's the way you do it. None of the parts in it are Ford, of course, but this is the way we're doing it. But the problem I had is your 454. It was a 454 rod with a 2.1 journal. This is a 2.0. I think that's a 2.0. And your heavy built motors take a 2.1. No, this is a 2.1. This is a 2.1. Big block Chevy is a 2.2. The rods I bought are big block Chevy with a 2.1 journal. 2.1 big end. Problem is, they've got a shoulder on them. They're wider by a hair. So when you put the two together like that to run on the journal, they don't fit. You can't get the second one on there because the fuckers are too wide. So what Jim's doing is he's milling off a little bit of each side to make it just like a 350 Chevy rod end. And that's the way you do that. But yeah, thinking back on it, I probably could have used these pistons right here. And I'm sure I thought of it, but I chose not to. Might be a foolish mistake. But I got these babies for a really good price. I'm proud of them. That's why I'm showing them off. My Weisico Racing pistons. And these aren't the junk ones. These are the good ones. They're forged, milled. Gosh, what is it? 2560? Is that what the alloy is? It's a really stout alloy. One of the highest tempered aluminum alloys that they make, I guess, for the high-end racing engines. Some machine shop either went out of, I think the guy went out of business and sold everything, and another guy picked them up out of an auction, probably in a box, and I was like, oh, I think I can get a good price off of these, and he put them on, and he put a good price on them, an exceptional price, and I got them. So this is what I'm using, and like I said, I could use these, so I don't know, I may end up buying a 6125 rod set and going with these, but I'm going to try to make these babies work, because after putting them on the crank and rolling it over, I am at a zero deck with these pistons and a 6 .385 rod. So this is going to be a badass machine, and I look forward to bringing you on that journey. I hope you enjoyed this, and I hope it brought you some knowledge. Ask any questions if you have them, and I'll do my best to answer them. If not, call Jim. He's the man. We'll see you.